Hello, astronomy class. This is Garrett Robinson, and today we are going to be talking about the sun. However, as we talk about the sun, we are not going to be talking about the children's television show, the Teletubbies, and why they put that incredibly creepy baby face in the middle of the sun. When you think about the sun, you might think about the long walks on the beach that you take as you look at the beautiful sunrise or sunset, or maybe just the fact that there's a giant ball of fire that's 93 million miles away. However, whatever you think about the sun, the reality is that without it, we would be dead. And even if we could survive, it would be really dark. And even if we could survive in the darkness, there would be no tasty food. It would be cold all the time. And because it's cold all the time, there would be no reason to go to the beach and get sweet tan lines. However, the question that we're going to be answering today is not whether or not the sun is important, but instead what is inside the sun. And how do we determine what's inside something that's so hot we can't touch, so far away we can't get to, and so bright we can't even look at with our own naked eyes? Because that is a really tough question. And scientists are super impressive for being able to answer it. The two primary means that scientists have come up with for looking at the inside of the sun without getting inside the sun are neutrinos and helioseismology. And these are both complicated things, so if you don't understand in the next minute and a half, that's a-okay with me. Neutrinos are something that are created through the nuclear fusion that happens in the middle of our big, beautiful star. They are almost massless particles which travel incredibly fast and interact with almost nothing because they're super antisocial. Unlike photons and other things, which take about 200,000 years to reach the surface of the sun, neutrinos almost pass through the sun like it's nothing. And that means that we're able to look at the data, which they can give us in 8.5 seconds, which is really important. And they give us a lot of good data, such as the rate of fusion, the central pressure, the temperature, and the density, all inside of the sun, which begin to help us paint a picture of what's going on inside. And it was interesting when we started looking at neutrinos that there was something known as the solar neutrino problem, which was essentially the fact that we thought X amount of neutrinos should be reaching Earth as they left the sun, but not that many were showing up, and we couldn't figure out what was going on. It was actually helioseismology which helped us figure out the solution to this, which was essentially that when neutrinos leave the sun, they split into different particles, which you have to have very sensitive things to measure these, and therefore we needed to readjust what we knew about neutrinos and how we measured them so that we could learn more and get more data from these things. And that was all thanks to helioseismology, which helioseismology is the study of the acoustic waves on the surface of the sun. It's essentially like giving a giant ultrasound to the sun, even though it's not pregnant, but it allows us to see what is going on inside. In the 1970s, we realized that the sun oscillates on about a 5-minute pattern, and that through that we can paint a picture, and studying these that we're able to paint a picture of what's going on the inside of the sun. The main way to do this is to look at Dopplerograms or study variations on a spectral line, but through this we're able to learn a lot about the magnetic field, which teaches us a lot about the solar weather and how that affects the space things that we send around in orbit and our Earth, and how all of this impacts us, and not only us but the other stars. And as we seek to learn more about the universe and different stars and how they're born and how they work and the inside workings of them, this has given us a lot of information for that. And it's actually cool because you can go on NASA's website and learn about their helioseismic and magnetic imager, which they sent up into space in 2009, and has given a lot of cool images and data about the sun and how it works and the magnetic field and all the different aspects of that. So hopefully through this you've learned something about the inside of the sun and the different ways that we're able to get and learn about what goes on inside the sun without actually having to go inside the sun. But there is a lot more information out there. Obviously this is not very holistic picture of that, but hopefully you learned something. And if you'd like to check out my references, here they are. I hope you are having a great day, and we will see you later.